Okay, Shalom, welcome. Do you hear me?
Yeah.
You have about 45 minutes. It is echoing. You know, I am listening to my voice. And you should, do you know how can you share?
Actually, no.
No? First of all, introduce yourself. And then you should share your PowerPoint slide. And it is on the right side down. If you click on it, then you will see an error which is directed to right side in the box. Bu kendi sesimi de duyuyorum. Niye böyle oldu acaba?
Hocam siz bence hiç çıkmadan bir daha mı bağlandınız acaba? 2 kere katıldınız sanki. Öyle mi
İşte
oldu?
bir tanesi senin adına olan katılan. Neyse eğer o konuşurken eko yapmıyorsa mesele yok. Burada. 2 defa mı bağlanmışım ben?
Ha, evet hocam 2 kere bağlanmışsınız. Çünkü diye moderatör olarak bağlandınız ya diğerine çıkmadan.
Şu anda nasıl? Şu anda sesim?
Böyle bir şey oldu.
Şu anda sesim geliyor mu?
Geliyor hocam evet.
Ha, tamam bu şekilde devam edeceğiz. Şu anda ekoya. Okay, Shalom, sorry about that. Can you hear me now?
I can hear you, but I don't know where I can share my screen.
You see on the right, Mehmet belki sen söyleyebilirsin. Bu sağda altta X işareti var. Leylaki renk.
Shala, there should be like a purplish like an arrow button on the bottom right corner.
Okay.
Onu after you click on it, then you will get 3 boxes, and in the middle you see an arrow which is directed to right side.
Okay.
If you come on it, you will see share content.
Share content.
Mehmet Bey sizdekinde görünüyor değil mi o share content?
Evet hocam ben görüyorum.
Okay.
Tamamdır.
Okay, just a moment. Repeat it.
Shala, that was good. We saw it shortly, like for a few seconds, but it went away.
Let me see. Okay. What about now?
Yep. We see the like your Zoom.
No, this is not your
You
power.
see the PowerPoint?
Yeah, we see.
Nothing.
We don't see the PowerPoint. We just see your screen.
Nothing.
Or
Black.
is this, what is this, like the black? Yeah, black. Just screen.
Okay, let me share. Can you see it now?
Yes. Okay, we are beginning again now. Shala, first of all, you have to introduce yourself to the jury members and tell about something about you. Tell something about you. And then you can begin with your presentation, but do not exceed about 45 minutes.
Okay.
Shala, you should especially focus on you don't have to really go through every single page of your slides. Just first give a overview, quickly explain the problem that you're solving in this thesis, and then a quick review of the literature, compare your work with others, and then mostly talk about the algorithm that you used. I really want to see how much of that you understand, and just explain to us how or which algorithms you used and how they work to solve the problem that you have here.
Okay. Should you start?
Yes, go ahead.
Okay. I am Shalom Abdullah. I'm nationality Iraq. I live in Kuwait City. It's in Iraq. So I study baccalaureate in Kuwait University, and I study magister at in Firat University. So I finished the software engineering department at Kuwait University at 2017. So my master topic under signature recognition using machine learning. That's my agenda in this presentation. I will. Can you hear me now?
Yes, yes. Continue, please. We are hearing you.
Okay. Okay. This is my agenda in this presentation. I will give brief information about information security, and then we will come to machine learning, an introduction to CMS network and convolutional CMS network, and then CNN parameters, and then one by one kernel and triple loss classification, then the data set that we train on it, and the pre-processing and the result, then the model interface. So information security is try to keeping data secure from the copier or from the Thesis, or as you know, information security try to secure information is from clouds and from our databases, or from the stores in the markets. So information security start with computer security during World War II. That's the history of information security, and brief information about information security, since we work on data security or information security. To building a system to securing our informations, we need to create system by machine learning. So machine learning is a part of artificial intelligence, or field of artificial intelligence. Is allow machine to learn without being programmed. It's learning with patterns, or we can say by features or characters from images or videos or audios. So machine learning have 4 sections. First, supervisor learning, and unsupervised learning, and semi-supervised learning, and reinforcement learning. Each of these have its work and its field of using. So where we are in these fields, machine learning, as we said, we have 4 categories. The first have Monte Carlo method. Then semi-supervisor have cell training and low density model. Unsupervised learning, we have clustering and dimension reduction and anomaly detection. In supervised learning, we have regression, which have 2 fields, and classification, which have these 2 fields, and deep learning, which we have 2 fields too: CNN, convolutional neural network, and RNN, recurrent neural network. So we are here. Deep learning, in the machine learning, we are in deep learning using convolutional neural network. Introduction to CMS network. CMS network is our double network. We have 2 or more than 2 inputs. We can take 2 input or more than 2 input. with sharing weights, or we can say sharing features or parameters between these two or more networks. The Siemens network can be measured by distance functions. We have two distance functions, distance metrics, triple loss and Euclidean distance functions. We are using triple loss functions because of some reasons. I will explain it in next slides. So the measurement is for classifications by Siemens network is loss functions. We have two loss functions, triple loss and Euclideans. Deep convolutional neural networks are convolutional layers which we have first we can encoding the picture, then we can dropping or outputting the features from the image by it, and feeding next layers. We can first we have convolutional layer, then we have pooling layer. Pooling layer feeds by convolutional layers. Then we can use fully connected layer, or we can use a triple loss function instead of fully connected. I explained triple loss. Then full Siemens network architecture is just like this picture. We have three images. As we said, Siemens network can take more than two input. So in triple loss, we can use three images. Anchor image which is referred to original image. Positive is a copy of anchor image, or someone signaged this picture. Then take another one from the same person, so it's positive. But negative is forged image, so it's from the stellar person. We convert this picture to block of image, or you can say block of embedding. Then we use bottleneck layer, or we can say one by one kernel or network in network kernel, to reducing the amount of feature. And then we get a feature map from this by using bottleneck. Then we will use others layers of convolutional layer, for example, pooling layer. Then we try to reduce by another process of this to get a block of numbers. Then these block numbers, triple loss take this block of numbers and calculate the result. This process is same for positive and negative. So this anchor, positive and negative. We'll try to explain this more. So why triple loss functions? Because triple loss functions, it's more speed in processing, speed in learning, and suitable with the TensorFlow frameworks, because we use TensorFlow frameworks here, TensorFlow library, and randomly selected inputs. So the biggest point, or the most benefit point in triple loss is selecting randomly pictures. And we have here three input, but in Euclidean distance, the reason why this we didn't use Euclidean, because we have two input, but in triple loss we can take three. So it's process more speed. So to explaining the triple loss function, we have D, it refers to distance, A, it's anchor image, and P is positive image, then n its negative margin is by margin we can determine how much difference should be between positive and negative sets. For example, if margin equal to 0.2, the margin is usually between 0.2 to 1. So we can change the margin between 0.2 to 1. It depends on the model that we training on. If it's 0.2 and the set of anchor and positive, if it's equal to 0.5, the set of anchor and negative should be at least 0.7 or biggest. So this image explains the work of triple cross. For example, if the initial anchor image have this distance between negative and between positive have this distance, after learning it try to decrease the distance between anchor and positive and increase the distance between anchor and negative. So that's the work of triplet loss. Then we come to CNN parameters. In CNN we have 3 parameters: padding, stride, and relu. We will explain by this video. For example, that's the stride by 1. So we should move 1 pixel to 1 pixel. That's the stride by 1. Padding, when we use padding, if the filter doesn't match the image, we should padding by 0, as we do it here. It's just like this to get this filter of, to get this block of number, this block of image. So this block of image is just like this at the end. But if we use 3x3 or 5x5 or 7x7 filter to a biggest number of feature map, as you know, if we go deeply into the image, we will have a lot of features, a lot of patterns. So what we should do to reducing these feature maps, because as you know, if the feature map is biggest number, for example, 120 million parameters, it's need a lot of time, it needs a supercomputer. So it's something unusual to using. So what we trying to do here to reducing this big of amount of number, we will use 1 by 1 kernel. So when we get this number, it's just like by crossing, multiplying, crossing, you will get this number. For example, 28 multiplied by this, and then 5 by 5, we will multiply by 1092. You will then get this amount of number. But by 1 by 1 kernel, we can reduce it to just 12.4 million. How? So by using 1 by 1 kernel or a network in network, which is developed by Min Lin in 2013, he developed these ideas, and this idea is very easy. we just need to focus here. So if we have the same block of image, same block, and using one by one kernel with the 16 channel, just by crossing, we will change the place of 1092.
This is not 1000. 192 you have to say.
Yeah, 1092.
No, this is not 1000. This is 192.
Okay, I'm sorry.
Yes, where is 1000?
Okay, sorry. 192. We will just replace by 60. Then crossing 192 by 1 multiplied by 1. So it's equal to 192. Same. If you calculate this to all, you will get 2.4 million. So the image here, you will get image 28 by 28. The channel will be 60. So if we use, then we will come to use filter. So before using filter, we should use one by one kernel to reducing the amount of big features. Then if you use a 5 by 5, for example, feature, we can use 7 by 7 and 3 by 3, but it's 5 by 5 is between them, so it's, I think, better. 5 by 5 with their two channel, we can just crossing again. 28 by 28 crossed by 32, then 5 by 5 crossed by 60, as that we get it from 1 by 1. So it's equal to 10 million. If we calculate the first image with the image that calculated or multiplied by the kernel 5 by 5, you will get 12.4 million. So by one kernel, we can reduce a big amount of feature or patterns to less amount. The benefit of using one by one kernel is reducing amount of feature map, reducing input size data to lower volume before making features, before using kernels 3 by 3 or 5 by 5 or 7 by 7. And it's need a lot. It's need less time and simpler mesh. I mean a simple network. So the network, as we can see here, it's not complicated to understand, because it's not complicated. It's easy to understand, not like fully connected, which is too complicated to understand. So that was the idea for reducing big amount of features. Then, when we get at this point, we will use others CNN layers. For example, we will use max pooling layer. In the pooling layer, we have max pooling. In the max pooling, we take, for example, this image, this block of image, come to these steps, and we get this output. By using a polling layer or max polling layer, we can just select biggest number in this, see biggest number here, biggest number here, biggest number here. So we will get this. So we will get this feature map. So the output of this biggest feature map is just this. Then we will try to convert this to a block of numbers. Then just addition between them, we will get one number. This one number, the triple loss function will take it. For example, it's anchor image. So the result of anchor image is just multiply addition between these numbers and feature and triple loss function take it. So it's same for positive image and negative image. That was the whole idea of the Siamese network architecture. So this architecture is easy to developing it by triple loss library, because they have ready functions, ready frameworks for developing triple loss, for developing one-by-one kernel, and developing full convolutional neural network. The data set that we use it here is Kaggle data set. This site, a website, call it Kaggle data set. We use their data set because we couldn't prepare our data set. The pre-processing, we don't need a lot of pre-processing because Kaggle datasets already do their pre-processing. We just use simple pre-processing by TensorFlow library. For example, decoding. This decoding, we use decode PNG function. And for resizing, we use scale. For padding, we use tf padding. So we just use 3 pre-processing because we don't need a lot of preparation in data set. The Kaggle dataset developers do it before. Training the model. As I mentioned, we develop the model by TensorFlow using TensorFlow libraries and some OpenCV library and Keras and Python. As you know, TensorFlow work with Python. The model was trained on Ubuntu. I will explain the benefit on Ubuntu. So why we use Ubuntu instead Windows? Because if we try to download TensorFlow library in Windows, we need support from others softwares. For example, we need to download Anaconda. Then in Anaconda, we should download TensorFlow, and then we should download packages of OpenCV. So it's time-consuming and need a lot of space. But in Ubuntu, just by writing pip install TensorFlow and mention the version of the TensorFlow that we need, it will be downloaded in at least 10 minutes or 5 to 10 minutes. But in Windows, I try hours to just downloading Anaconda. It's need a lot of time. Ubuntu is more secure and fast operations. Is suitable for machine learning workers. The table below explains the tools and software that we use it. We use operating system Ubuntu version 18.04. The program language Python 3. The TensorFlow is 1.40. Kira, we use Keras, and neural network, Siamese neural network type. The version is convolutional Siamese neural network, OpenCV. For developing the interface, we use Java Spring Boot, and Rakit JavaScript. The classifier was triple loss. The triple loss, we have two kinds of triple loss, offline and online. So the reason we use offline, because our system is work offline, not online. The result,
Shalom, I don't know if you clearly explained what you are doing exactly. What are you classifying and what this data set is? You just said like you received that or you retrieved it from the Kaggle data set, but you didn't mention what it is and what you are trying to do. Can you just briefly say that before you present the results? Like the signature.
We need to see the.
Okay,
Yeah.
so yeah. So
Okay.
you are doing like a signature verification. So you didn't really explain clearly what what you're classifying, what your data set is, the contents of the data set. So
should I show you the data set?
No, it's no, it's fine. Well, Shalab is trying to classify signatures. So and the data set that he got is from the Kaggle data set. He's using that, and that's what I mean. You didn't really say what you were doing. Okay, you can continue, but you have only probably 10 minutes left. Just make sure that you cover everything, and there might be questions. So yeah, go a little faster.
So we come to the result. The result after 180 steps, we get the 0.8, which is 84 accuracy. So it's good accuracy because we will try here to getting more to getting low loss and high accuracy among these results. So the high accuracy was 84 and low was 0.49. The model interface. The model interface web application developed with Java Spring Boot. We use some HTML and CSS to make the web application more good or more beautiful. And for the backend, use Rakit JavaScript because it's already suitable for with the Java Spring Boot. For connecting between model and interface, we first should convert the model to .pb or protobuf file. Protobuf file contain all feature maps or contain all the results of the images. For getting the result from this file, we use get post, just get post methods. We can use TensorFlow.js instead of it, but get post is more speed. The interface is just like this. We have 3 parts: user list, enrollment, recognition part. So in the user list, it shows us all the users that we registered them. In the enrollment part, we are trying to registering the users. For example, in name, you will give it name, and the image will choose the images, and you will just submit it. So it's just like a simple web application. Try to uploading image. So like I said, it's get on post. Then in the recognition system, in the recognition part, you will try to get match between the image that we selected here and the image registered in the system. The log distance is equal to the image that we selected here. So it's just to compare all this system is just to compare the distance between 2 images. How the distance between is between these 2 images. If it's low, so for example, the user record image or signature, the distance between record signature and this signature that we selected here is 17, and for Hiwa is 30, so it's 33. So but for Sangao is 1, so the log distance equal to this image. I will explain in the interface. If you let me, I will show you the application. Hope it's clear.
Yes. Okay. Now show. Do you want to show your application now?
Yeah.
Okay.
I already run the application. If you can see it.
No, we cannot see. First of all, you have to share it. I think this is the old screen now.
Just hold me a second. Okay. So first, we will enrollment user. For example, and we will choose the signature of this user. I will just pick 5 to be speed uploaded. Then we press submit. So the user Sangao is recorded. We go to back to this. We will see Sangao user. Have 5.
We cannot hear you.
You can hear me now?
Yes, we can hear you now.
Okay. So user Sengal, we pick 5 signature. The user Sengal 5 signature. The result of this signatures was embedding for, the whole process for Siamese network equal to 5 embedding this. That's for picture 1. For picture 2 equal to 0, and others it doesn't show here. I don't know text field. There's an error in text field. That was about enrollment. I will enroll another one. User 2.
Shalom, are you speaking? Shalom. Kesildi, gitti. Yeniden bağlanacak. Ha. Şalav yine çıktı herhalde, değil mi? Çıktı gibi sanki de. Evet. Ok dışarıya gidiyor. İsterseniz biz bu arada biraz şeyleri konuşalım. Bu Kaggle dataset nerede yayında bu? Kullandığınız veri tabanı.
Hocam bu Kaggle diye bir şey var hocam, site. Orada insanlar şeylerine, datasetlerine public olarak yayınlayabiliyor. Oradaki datasetleri kullanıp işte değişik algoritmalar falan, yani çok kullanılan bir site, bir paylaşım yeri. Yani bilimsel çalışmalarda çok kullanılıyor oradaki datasetler. O da işte oradan bir tanesini alıp onu kullanmış. O şekilde yapmış. Yani bunu ben aslında yine Adıyaman'dayken bunu yapmış. Evet hocam, buyurun.
Ya hocam, o bir tane tablo gösterdi ya, bu eğitim sonucu.
Evet.
Ya hocam, o tablo, ya bir daha bakalım, belki o şey ya. Şimdi orada sol tarafta eğitim kaybı, training loss hiç değişmiyor. 0.49.
Diğeri değişiyor değil mi? Evet hocam, o benim de dikkatimi çekti şimdi gösterirken.
Evet, diğer tarafta ise accuracy işte çok böyle
artıyor falan değişiyor. Evet.
Evet. Yani çok orada bir tutarsızlık var. O tablo çok sıkıntılı bir tablo, onu nasıl elde etmiş?
Evet.
Bence bir yanlışlık var orada yani.
Bir de sayfa 28'de bu 3 tane kişinin mesafelerini gösterirken mesela Sengav için 1.81 distance'ı göstermişti. Bu Rickout ve Hiva için de 17 ve 33. Bunlar bu kadar fark edebilir mi? Niye bu farklılar bu kadar birbirinden uçuk? Acaba? Acaba nasıl açıklayacak? Sayfa 28'de. Sayfa 28'de. De mesafeleri veriyor eğitim sonrasındakine. Yani bunlar arasında böyle bu kadar büyük şey olabilir mi? Büyük farklılık. Bir de bu son gösterdiğinde rakamlar çok iç içe girdiği için tam okuyamadım ama mesela Sengav için verdiğinde hani 5 tane imza aldı ya orada. 5 tane imzayı aldı. 5 tane imzayı kıyaslamasını yapıyor. Bu imzalar arasında o kadar farkın çıkması atılan imzaların birbirinden çok kopuk olmasından mı kaynaklanıyor acaba?
Orada hocam o 5 tane imzayı yüklediğinde orada bence şeydi o yeni bir tane enroll yaptı ya orada training yaptı. Sonra recognize'da şey çıkardı hocam. Classification yaptı yani. Bu şey arayüzünde hocam bu embeddings tam olarak ne onu ben
Evet,
bilmiyorum yani.
embedding,
Tam olarak
evet,
o arayüzde
embedding.
Orayı diyorsunuz değil mi?
Evet, orayı
Evet.
diyorum. Bir de bu bottleneck'ten bahsetti. Bu bottleneck'i kullanmanın sebebi ne? Şey mi? Eğitimi düşürmek midir? Onu bilmiyorum. Belki Fatih Hoca daha açıklar. Çünkü Fatih Hoca bu alanlarda çalışıyor.
Yani bottleneck orayı tam görmedim de hocam.
Başta o verileri alırken işte burada bir şey var. Hani deriz ya şişe boynu, orada bir daralma var. Daralmayı ne için kullandı acaba burada? Niye daralma yapmak gereği duydu?
Yani benim aslında aklıma yatmayan başkasında şey vardı. Şimdi diyor ki ben diyor bu triple loss'u hızlı olduğu için kullanıyorum.
Hı hı.
Ama tam tersine 3 katı bir network'a gidiyor. Yani normalde sadece tek bir network'ken
Hı hı.
şimdi siz tek bir network'ta signature'ı tanıyabilecekken alt alta 3 tane network koyuyorsunuz. Diyorsunuz ki bu şekilde tanıyorum. O zaman 3 katı yavaşlar o. Hani 3 katı tam tersine bir söylem geldi. Diyor ki hızlandırıyor. Ben orayı çok anlıyorum. Nasıl hızlandırıyor ama.
Shalom, welcome. Your internet line is broken.
Yeah, we have big problem with internet these days.
Okay. Actually, we want to ask our sonuçları dinleyelim mi? Ne diyorsunuz sonuçlara? Bir kıyaslasın mı orada tekrar?
Bence hocam sorularımı önce Fatih Hoca'nın o sorduğu kısmı şey yapalım. O tablodaki sonuçlar niye öyle çıkmış? Onu bir açıklasın. Nasıl öyle çıkmış?
Shalav, can you showed a table to us and you compared the results and it was a big differences. Can you bring the table tablonun numarasını biliyor musun? Slide numarası? What was the
Training table. Training table.
Training.
Can you open it?
Yeah, training.
Training?
Yes.
Okay. You mean this?
Yes, this table. Bak en başta step 20'de 0.49 hatası. Yani bu öğrenmemiş network'un hatası. Accuracy çok yüksek. Öğrenmemiş. Daha bismillah başlıyoruz. Hani network daha öğrenmemiş. Accuracy çok yüksek. Öğrenme işlemi devam ettikçe accuracy düşüyor. Yani hiç öğrenmiyor. Da karma karışık ediyor kendisini. Ama loss düşmüyor. Loss'a bakıyoruz hiç değişmiyor. 0.49, 0.49. Evet. Yani bu aslında ben öğrenme yapmadım diyor şu loss. Tam yandaki sütun da diyor ki hayır diyor ben öğrenmeyi bir öğreniyorum bir öğrenmiyorum. Yani ikisi arasında tutarsızlık var.
Mesela
loss'la accuracy.
Evet, 160. adımda çıkan sonuç 0.48 accuracy. Değil mi? Doğru.
Yani hocam loss, tabii loss sütunuyla accuracy sütununun çok tutarlı gitmesini bekleriz. Loss başlangıçta çok yüksek hata, accuracy'nin düşük olmasını, ilerleyen süreçte de bunun tersine dönmesini isteriz. Loss azalırken accuracy'nin artmasını bekleriz. Doğal olan budur. Burada çok baş ağrıtacak bir tablo bu. Hani bir taraftan loss hiç değişmiyor. Diğer taraftan accuracy çok değişiyor. Ya ben bir öğreniyorum, bir öğrenmiyorum.
Evet, yani bir şey yok değil mi? Orada bir tutarlılık yok yani. Bir düşüyor, bir artıyor böyle. Salınım yapıyor yani.
Yani bu sütunu tamamen ortadan kaldırıyor. Yanlış diyor. Evet. Oysa bu ikisi çok aynı network'un 2 metriği bu. Hani aynı ağdan alınan 2 tane metrik bu. Tutarlıysa tutarlı. Yani loss'la accuracy tutarlı gitmek zorunda.
Mehmet Bey bunu sen mi
Burada bir
açıklarsın?
sıkıntı var hocam.
Shall I? Yok hocam ben açıklayamam yani sonuç niye böyle çıkmış bilmiyorum da.
Yo değil
Shall I?
sen
Did you understand the question?
No, I
Okay.
don't know.
Okay, so the question is, when you look at this table, the training loss doesn't change, almost like never changes. It's like 49%. It just remains at 49
Yeah.
all the way till the 180th step. But when you look at the
Yeah.
accuracy, it fluctuates. Like, you know, first, like, you know, it's 80% and it goes down to 60 to 32 and then goes up a little bit and then down. So there's not like a correlation between your training loss and the accuracy. So how do you get the result like this? So this indicates that.
Actually, we must change the learning rate. We start with 0, okay? Then learning rate will increase it. But we need a time first, and then a big supercomputer to make this less, for example, make losing less loss. 0.49 is the big number for losing. I know this, but it's not in my hand. I didn't get a supercomputer to training more training. Actually, 50 signature is less signature. We need at least, for example, 100 signature for just one user. But it was not in my hand. I didn't get a supercomputer to training. I think that's why training loss is more.
But this doesn't really show that like your algorithm is learning properly from the data set. So, and how is the accuracy is fluctuating like that? So, I mean, you don't know, maybe like, when I look at this table, if you run, let's say 20 more steps, I wouldn't be surprised if the accuracy went back down to like, 40% or something like that. So, yeah, you need to like look into that and see what is going on in the training loss and the accuracy.
Yeah, I tried too much to just get AT here and IT here.
Shala, in a data set of Kaggle, how many signatures are there available for the same person?
I think there was 15.
15.
Yeah.
Mm-hmm.
But I deleted some users. The users was more than 100.
You say you deleted them?
The users was more than 100. So I just decreased some users.
Why did you do that?
Yeah, I explained it because my computer is not supercomputer to work on training between 12 hours to 25 hours.
I mean, it shouldn't really like, you don't need a supercomputer to process 100 users or like 100 data, pieces of data.
Dr. Mohammed, I changed my computer because the last one I trained on it, the RAM was burned.
I am not sure about your speaking. I mean, really, do you need a super computer for it or not?
Of course, if we use more user and more signature, we need good quality of the computer.
Fatih Hocam ne diyorsunuz bu işe? Yani illa süper bilgisayar olması mı gerekiyor bu şeyi eğitmek için bunlara?
Yok hocam, hani şimdi Kaggle'daki datasetlerden bakın burada 30 tane user'dan 15'er imza toplanmış. ne yapar? 30 çarpı 15 yapar. Bu kadar data var. 450 tane imza var.
Hı hı.
Bu çok küçük bir dataset. Bu klasik bir bilgisayar bunun
Evet.
için çok yeterli.
Hı.
Şimdi ama arkadaşın dediği şimdi böyle big datalar olsun. Hani milyonlar videonun olduğu, boş ver imzayı, videonun olduğu, milyonlarca videonun olduğu şu datalarda süper makine ihtiyaç olabilir ama bu sonuçta 450 tane imgede şey yapılıyor. Bir tane imza veriyoruz. Bunlardan hangisine çok benzer? Bu sorgulanıyor. Bunun
Yani
için süper bilgisayara gerek yok hocam. Hani yani
Hı.
şey
Evet.
yani bu training şurası çok sakat hocam. Yani bu böyle bir hiç bilimsel bir şey tablo değil. Çok başarıcı bir tablo. Çok yanlış bir tablo yani bu. Çok büyük bir tutarsızlığı böyle ifade ediyor burada. Bu yanlış bir training sonucu koyulmuş buraya. Hani bunu düzeltmesi lazım. Bu yaptığı trainingi bir daha bir kontrol edip o
evet.
sonucunu burayı düzeltmesi
Hı
lazım.
hı.
Yani
Şala.
şimdi hocam ben şimdi
He.
o tablonun olduğu sayfaya bakıyorum da orada bir de şey de yazmış. Onu ben gözden kaçırmışım. Model diyor i7 CPU 11 GB memory ile 2000 saat train edildi diyor. Shalab, is
2000
is
saat.
that accurate?
Vay baba.
2000
Shalab,
saat.
Yeah.
can you explain that statement
But I
in
think
your thesis and
uh,
in page 27?
sen.
You
Yeah.
are saying that you trained the model on i7 CPU with 11 gigabytes memory for up to
Yeah.
2,000 hours.
Yeah.
What does that mean exactly?
Actually, I read in some references to calculating the time that you needed. You need to calculate all days you work it on the training. From building, when you build the model, when it's ready to training, from this to the end to get this result, good result, you need to calculate all times to tell others I work in this time.
Ben bir şey söyleyebilir miyim? Şimdi bu arkadaşın bu training loss'u gördüğü zaman training'i durdurması lazımdı. Demek ki hiçbir şey öğrenmiyor. Benim burada loss function'larında bir problem var. Bu hiçbir şey öğrenmiyor demesi lazım. Şimdi bu şekilde mesela 80 kaç gün hesapladım. 83 günlük bir eğitim yaptım diyor. 2000 saat 83 gün tekrar ediyor. Şimdi bu şekilde 83 gün değil 80 yıl da beklese o training loss hiç değişmeyecek. Hep böyle devam edecek. Yanlış yapmış. Yani,
And Shalal, like I think your statements, are very inconsistent. Hocam ben şunu bir
Evet.
ben paylaşabilir miyim bir ekranda şu
Tabii
sayfayı
sen,
göstermek
sen
için
değil,
özellikle?
tabii.
Nereye gitti? 26. Let me.
O çıkmadan paylaşabiliyor musun yoksa çıkmasın mı lazım? İnşallah.
Bir deneyeyim. Görüyor musunuz hocam? Ben ekranı.
Yok daha görmedik. Ha şimdi gördük evet. Ama tamam evet.
Shalal, do you see the screen? Like this is your thesis. I'm looking at this paragraph right here.
That makes it. Yeah.
Okay, so here you said that you trained the model for up to 2,000 hours. And you're saying that the decrease in loss, but there's not a decrease in your training loss.
No,
You say
I
the
mean,
decrease in loss and increase in accuracy slowed down significantly after 500th hour of training, but further training significantly enhanced performance.
yeah, I mean, can you see the slide?
Yeah, let's just, the table is here too, like right here.
Yeah. So, what I mean in loss in decrease in the loss, I mean the smallest loss, we will choose smallest loss and choose the biggest accuracy. So the biggest accuracy is 84, and but the more decrease.
No, but here, look at this statement. You're saying that the decrease in loss and increase in accuracy slowed down significantly. Where is that, like, you know, slow down, significant slowdown here that you're referring to? I don't see any significant slowdown here.
Yeah, maybe I mistake in writing, but I mean we will choose decrease, loss decrease, and increase, and more increase accuracy. There's a mistake in writing.
I mean, it looks like this entire part, your results, are not really like relevant to what you're doing. So this result is not something, it doesn't sound like something that you did or you obtained. You know what I'm saying? Like are you telling us that you trained the model for 2,000 hours? Is this correct?
It's not big days. I think it's 20 days.
Say it again, for 20 days?
Yeah, it's 20 days.
But even 20 days for like 30 users is like a really long time. I don't know how long. Probably this would take, I don't know, like a few minutes.
Yeah, 20 days working each day about 8 hours, I think.
I'm not sure if you understand
That's
the question.
You have problem with the time?
No, do you understand what that time means exactly? That 2,000 hours? What is that? Can you explain to us?
The reference said from day you training the model, day you start the model.
Who?
References. That's not my set.
But you're talking about your own algorithm. What do you mean, the references?
Yeah, the references that I back to them to calculating the time.
I think what happened here is Shalal saw somewhere in another publication that they trained their model for 2,000 hours, and then he just took it from that and then claimed that he trained his model for 2,000 hours.
No, I didn't do that.
But you're just saying that your references said that they trained for 2,000 hours.
No, I mean for calculating the time, not I copy from them. It's my own work. I work on the training.
But how did you calculate the time? Like you have, I don't understand how you're getting this like training hours and then how you, where you saw the training being significantly enhanced or like improved.
Previously related work, how calculate the time, I do same like them. For calculating the time, I do the same. They start from the day that they trying to calculate time, trying to train their model from 0 to, for example, they need 20 days. How many time?
Yeah, let's say you calculated it. How, from like 30 users, how did you calculate 2,000 hours?
Hocam o eğitimi başlatmıştır. 80 gün sonra durdurmuş. Bunu bu şekilde hesaplamıştır. Hani,
yani 80.
Yani diyor ki ben diyor eğitimi başlattım diyor. Bu 2000 saat eğitimi sürdürüyor. Yani 80 gün sonra bilgisayar 83 gün çalışmış. Sonra eğitimi durdurmuş. Bitmiş.
Yo, ama şey diyor bir de ben öyle hesapladım diyor diğerlerine göre de. Shalal, how long did your training take?
Can you repeat the question?
How long you're training your algorithm? How long did it take?
Just training.
Yeah, how long did it
20
take? How many hours?
20 days to 20 day to 25, I think. Just training.
20.
I don't include developing. Just training. Day to 25.
So these, like, you know, from this phase 20 to phase 80 that you're showing, it took like 20 days.
Yeah.
Evet,
Bilmiyorum hocam,
istersen şey
başka
yapalım. Başka soru. Okay, the other question is, in your slides you discussed about bottleneck. Do you remember?
Yeah.
What is the reason for it to use this term in your thesis?
Bottleneck is just another word to one by one kernel or network in network kernel. Just another name.
Another name.
Yeah.
What do you mean with another name?
Yeah, in network paper, which is published in the 2030, I think, by Nguyen. He named one by one kernel by network in networkers, and some references then developed the one by one kernel. They name it bottleneck. So I use all names.
I see. And during your presentation, you have to pay attention to the vocabularies. I mean, for example, you are investigating deep learning, but you wrote deep learning wrong. D-E-P-P, you wrote. For example, Euclidean, you wrote Euclidean term as Euclidean with E. This is very important because you are focusing on some terms, but you are writing with wrong vocabularies. You have to pay attention when you are preparing your thesis.
I'm bad in vocabulary, sorry for that.
But it's important.
Yeah, there's actually one more thing. Can you show us your thesis again, the latest version, the final version, and go to page 4? I just want to make sure that I have the latest version that you sent me.
Page 4.
Yeah, can you share your screen so we can see it too?
You need to. Okay. You need to see slides or the thesis?
No, your thesis.
Okay, let me. You need page 4?
Yes.
Okay.
But I'm not seeing anything right now. Go up to the preface. No, go up to the preface. Go up a little more. I want to make sure that like, you didn't include that in your actual.
Here.
No, go up more.
Okay. Introduction.
No, the preface.
Preface.
Okay. Okay.
I want to make sure you change that part.
This.
Yes.
Okay.
Okay, so you changed that. Okay. All right. Yeah. So never mind. I wanted to see that you changed this part because you had like some incorrect information.
Yeah, I know there was.
And do not forget to put their doctor degree. Prof, supervisor, prof, doctor.
And mine is mine should be assistant professor.
Yeah, assistant professor. Type the correct titles.
Okay. I will check this.
Okay, I think it is enough for presentation, and you can leave now, and I will type to reconnect to the room, and we will tell you the result. Okay?
Okay.
Shala, now please leave the room.
Just 1 minute.
Okay, I can remove you, I think. Tamam. Şimdi onu uzaklaştırdık. Evet. Şimdi Fatih Hocam, isterseniz sizinle başlayalım. Çünkü siz bu konularda çalışma yapan birisi olarak sizin söyleyecekleriniz önemli. Önce sizi dinleyelim. Sonra
Hocam,
danışmanı dinleyelim.
Oradaki eğitim yapılan yapılan eğitim sonucu bence teze doğru aktarılmamış. Orasının düzelmesi lazım hocam. Hani ben uzun süreli bir eğitim yaptım diyor, 80 günlük. Onun tabloya aktarılmada hocam da mesela, Mehmet hocam da baktı. Ya diyor burada kaçta 500. iterasyondan sonra anlamlı bir düşüş oldu diyor.
Yani
Ama hem orayı göstermemiş, hani onu göremiyoruz tabloda. Hem de 500'den üstte tutarsızlık çok büyük. Yani bence o eğitimi güzel aktarsa en azından şey olmaz. Böyle bir facia
Peki
gibi
genel olarak tezi nasıl buluyorsun genel hatlarıyla?
Bence sonuçta o şeyi de öğrenmiş hocam. Hem training yapmayı öğrenmiş, bir web sayfası hazırlamış, imzayı oraya yüklüyor. Yani yüksek lisans öğrencisi için uygun görünüyor hocam.
Uygun görünüyor. Evet. Ben de seninle aynı görüşteyim. O tabloyu düzeltmek şartıyla, onu Mehmet Bey de yardım etsin bence kendisine. O kısımları düzelterek doğru sonuçları yaparsa bir tezde, yani epeyce çalışmış, belli çalışmış ama ne yaptığını bilmeden çalışmış. Yani orada sen mesela iyi yakaladın. Yani dediğin gibi loss'lara bakıyorsun. Ondan sonra diğer tarafta accuracy'ye bakıyorsun. İkisi arasında tutarsızlık olduğu gözüküyor. Dalgalanmış sinüs gibi. Yani onlar bir de sizin de ortak düşüneceğiniz, hani bu kadar sürer mi? Bu 2000 saatin ne olduğunu bilmiyor, yani o çıkıyor ortaya.
İşte onu yanlış yapmış.
Evet, yani belki de orayı 2000 saati yanlış 20 saat mi diyecekti acaba yoksa? Bilemiyorum ki.
Yani inşallah öyle demiş. İnşallah yanlışlıkla demiştir de. Yani bazen de şey oluyor, sanki bence inşallah başka bir yerden alıp da şey yapmamıştır onu. Yani onu sanki şey demeye çalıştı ama böyle hesapladım falan, ama neye göre nasıl hesapladığı da belli değil. Direkt işte, yani açık bir şekilde orada söylenen şey 2000 saat train edildi yazıyor yani. Başka bir yani hesaplama falan
yani
değil.
Şu da oluyor. Hem Mehmet hocam şu da oluyor. Mesela Kaggle'da bunu 2000 saat eğitmişlerdir. Network hazırlanmıştır. Sonra araştırmacılar kendi çalışmalarına onu transfer learning yapıyorlar. Hani eğitilmiş, learn edilmiş network alıyor, kendisi imza için kullanıyor mesela. Bunu yapıyor. Onu belki ifade etmiş olabilir.
Yani
o zaman,
kendi train ettiği network'le şeyde kullandığı aynı değil. O zaman.
Aynı değil. Mesela Kaggle'da eğitilmiştir. O 2000 saat eğitilmiştir hakikaten örneğin. Bir network çıkmıştır ortaya. O transfer learning ile kullanıcılar onu alıyorlar. O da olmuş olabilir. Hani kendisi almıştır. Hani kendisinin oturup 83 gün onu train etmesi hakikaten şey de geliyor. Çok tuhaf bir şey geliyor. O da çok zor yani. O belki o ifadeleri düzeltirse hocam oraları biraz düzeltmesi lazım.
O zaman ben kendisini odaya çağırayım. Sonuç olarak olumluyuz. Yalnız şimdi bunu kabul ettiğimizde bir ay içerisinde bitirmesi lazım değil mi? Mehmet sen ne diyorsun?
Yani evet, o sonuç kısmının çünkü tezin zaten önemli olan kısmı orası. Yani kendi yaptığı iş orası. Oranın değişmesi lazım. Oranın bence yeniden yazılması lazım. Hatta oradaki ifadeleri yeniden yazması lazım. Yani bu durumda bence sanki kendi network'ünü tekrar train edip sonuçlarını tekrar double check etmesi lazım diyeceğiz de o da ne kadar sürer bilmiyorum yani. Şimdi 20 gün sonra dedi ya 20-25 gün train ettim o kadar sürecekse bir ay içerisinde mi dediniz hocam?
Şimdi kabul edildiğinde bir ay içerisinde olması lazım. Yoksa biz 3 ay uzatma verebiliyoruz. Ama 3 ay uzatmadan sonra bir daha almamız gerekiyor. Sunumu almamız gerekiyor. Yani o kabul edilmemiş ve bir bakıma kabul edilmemiş. Şimdi biz bunu kabul edeceksek bunu bu sürede bitirmesi lazım. Bir ay içerisinde teslim etmesi lazım. Bir ay süresi var normalde.
Değişiklik isteyip de kabul etmiş olur değil mi bu durumda?
Yani biz şu anda kabul ediyoruz ama ne yapmıyoruz? Kapakları imzalamıyoruz. Bir ay bekletiyoruz yani. O bir ayda onları yapıp düzeltecek dediğimiz şekle sokacak.
Tamam. Tamam hocam.
Tamam, hemfikir miyiz arkadaşlar?
Aynen hocam.
Tamam. Okay, Shalav. We discussed about your thesis together and finally we decided to accept your thesis but with major correction, not minor. It means the conclusion chapter of the thesis should be rewritten. As you saw, the table was not so clearly what you wrote there, and the hour you indicated 2000 hours. It is not acceptable. There are something wrong. And if we compare the results of your table, then this table shows there are something missing in your thesis. Normally you have about 1 month, maximum 1 month, because otherwise we have to reject your thesis and give 3 months to you. But the ideas of the jury members decided to give 1 month to you, but you said you wait 20 hours to train the data. It is really so long. Then 1 month will not enough for you to complete everything.
Yeah, now what should I do?
I don't think it will take. I'm not even convinced that it will take normally 20 days to train. I think you will get 1 month and then just retrain your network and just see how you can, what the problem is and how you can change the training loss and the accuracy so that it reflects that the algorithm is, or the network is indeed learning. Okay, so that part, you need to repeat that part and try to improve that. And because that table is the most important part of your thesis, but it's not showing what you are claiming in your thesis. It's not showing that your algorithm is learning consistently over 20 days or whatever, however long you run that.
So I need to retrain the model.
Yeah, that part, was it the conclusion where you discuss the training loss and the accuracy of your network? You need to figure out what the problem is, because normally you expect the training loss to decrease and the accuracy to at least like somewhat consistently increase over a period of time, but we don't see that in your results.
Did you understand? Otherwise, we can give 3 months to you, but it means we should reject at this point, and we should give a while to correct all of them. Which one is suitable for you?
I don't know if I can get good computer to training.
Because you know, you will get married with these Thesis, and your supervisor is responsible for it, and all Thesis are released on internet. Therefore, in future, you will face with difficulties if this table is stayed there, and therefore we should be sure about the results as jury members. Otherwise, we cannot accept with the wrong data results.
And also, you should make sure that you clearly explain what you did. If you didn't train the network for 2,000 hours, you shouldn't say that you did train it for 2,000 hours in your thesis.
It's just calculation. It's not on my hand.
No, but you said that you didn't train it. I'm not still quite sure where that you got that 2,000 hours from. So if that's something that you did, you shouldn't include that in your thesis.
Can I calculate the hour for you?
What?
Can I calculate the hour for you?
Okay,
How are you going to do that?
but you already wrote there that you trained 2,000 hours. How did you calculate it?
It is just calculating the hours that I work in days, in these 20 days.
That you worked, or you trained the network? I don't understand.
Training the network is on my computer. How many time could my computer work in these days? It's this number.
Ben tam olarak ne demek istediğini anlamıyorum
Evet,
açıkçası
yani
hocam.
Ruth yani anlaşılan bilgisayarı açık koymuş. Ondan sonra işte 20 gün sonra durdu.
It's not clear. It's not in my hand.
It's not in your hand, but you expect the algorithm to learn. Like, you know, what you're saying is when you train an algorithm, in order to get a successful result, you have to show that the accuracy is increasing and the training loss is decreasing. So if you don't get that result, that means there's something wrong, or like, you know, you're not doing something right.
Yeah, you are right, but I didn't get a good computer to training. That's the big reason. I told you when we was
Shala,
in the Elazi.
Shala, listen to me, please. You know, Dr. Talo, Mohammed Talo is an expert in this area, and he published a lot of paper. And he said, this is not possible to need a huge computer, supercomputer with so much or so many datas. There are something corrupted, in my opinion, because an expert
Actually,
this is so.
Oh no, but I changed two computer. They run Burnet. That's my third computer I use. I even increased this quality of hard and quality of RAM.
Okay, buna o zaman 3 ay mı verelim ya, bunu reddedelim, 3 ay verelim, çalışsın bu işi yapsın, yani yapacağı o. 1 ayda yapamayacağım diyor, yani yapamayacaksan nasıl kabul edeceğiz bunu yani? Asıl tezin en önemli noktası da bu değil mi?
Aynen öyle hocam. Bu biraz bu training'e bakması lazım bu arkadaş. Yanlış yapıyor.
Okay,
Yetişemem.
okay, sorry about that, but we cannot accept when you didn't, when you don't change anything in your thesis in terms of conclusion part. Therefore, my suggestion is that we will give 3 months to you, and you will correct everything and working on it, and then your thesis can be accepted. Because you say I cannot finish in 1 month, as I understood correctly.
I don't know what should I change.
The table is wrong. The table is wrong, and the data are not consistently.
I can record the training. I can record the training and I will send it to you.
If you use the model inconsistently, then the results will be wrong. We are not sure whether or not you use the correct way for it.
I don't know what I say, but I can't use big data. Then I will train it. Then the model will be stopped because the RAM and the hard doesn't have this space to contain all this data. The model will be stopped. I can show you by the recording.
Fatih Hocam ne önerirsin? Burada ne yapsın? Bu çalışmasını bir videoya çekip kısa bir videoyla doğru yapıp yapmadığını nasıl emin olacağız?
Ya hocam,
Hocam yani o sadece bence sonuca göre, yani şimdi sonuçta bu classification problemi sadece o gösterdiği tablonun network'ün öğrendiğini gösterir şekilde sonuçları ifade etmesi gerekiyor. Yani istediği kadar record etsin, eğer yani sonucu doğru bir şekilde alamıyorsa yani bir problem var demektir. Yani bu hardware kaynaklı da olabilir ya da belki algoritmayı kullanmasında bir sıkıntı vardır ya da datasette. Yani onu bence sadece kayda bakıp da şey yapamayız yani.
Değil mi? Onu
şekilde
söylemez. O zaman bilmiyorum, benimle aynı fikirde misiniz?
You know, like the results, yeah, we said that the results are not acceptable as it is to be, like, you know, included in your thesis. So that part needs to change. How long do you think, like, you know, it will take from you to, you know, work on that and then change it?
Give an exact date to
olabilir
us.
mi hocam? Yani bir ay mesela
Ya onu
şimdi
söyleyecektim. Yani şöyle bir şey yapabiliriz.
bekleyip bir ay içerisinde bitir.
Yani şunu da söyleyebiliriz. Bu Covid'den dolayı buraya gelememesi vesaire deyip bu bir ay içerisinde değil de bunu 1,5 bilemedin ki aya sarkıtabiliriz yani. O şekilde yapabiliriz. Çünkü bu Covid'de
Tamam hocam,
bazı Covid'de sıkıntılar var yani. Covid'den dolayı şey demiyoruz. Böyle her şeyi zamanda bitiremiyoruz. Bunun için de özellikle hatta isterse dondurabiliyor da süreyi. Dondurabiliyor da. Ama o dondurmayı geçti yani. Daha dondurma değil, tezi direkt sunuyor. Bence biz buna bir ay verelim. Bu bir ay içerisinde bu daha ne kadar zamanda getiririz. Ama tabii bu 3 ay filan vesaire de getiremese o zaman yapacak bir şey yok. Tezi reddedilir. Okey.
hocam yani çalışmasının tam olmasın getirsin hocam.
Okay. Shalav, you will complete your thesis according to your supervisor's advising. It means you have to follow his advising and change everything what he wants. And normally we are expecting that you will complete everything in 1 month, but because of COVID disease pandemic, we can write to our graduate school because of this condition, we must give a tolerance for Shalom. We can do that. This is the solution, and we don't have any other way to suggest you.
I need just 1 month. Okay.
Okay, this is a minimum, but if you cannot complete in 1 month, then we can give a little bit more tolerance to you. For example, 1.5 month or maximum in 2 months, you have to complete everything.
Okay.
and you will contact with your supervisor, and he will advise you. Because you know, although we accept your thesis, but the results are not correct, and please think about your future. With this data, if you indicate this data in your thesis, in future you will get trouble. Not you only, me and Dr. Talu and Dr. Mehmet together. Because if somebody says which kind of the results are there and everything is wrong, then we will have a really big problem with the scientific, in terms of scientific ethical issues. Understood?
Yeah, I will try.
Okay, congratulations, you passed, but unless you bring the correct version of your thesis, you cannot get your diploma. Do not forget it. This is very important.
Okay.
Okay, so have a nice, and I hope you will finish your thesis on time, and Dr. Kaya will steer you what you should do.
I will send you an email and explain to you what you need to do and what you should change.
Okay, so
Okay.
okay, thank you,
Okay,
thank you,
have a
Shala.
good
Have a
day.
nice day, have a nice evening, and do not break your connection with your supervisor. Okay,
Okay.
have a nice day.
Okay. Congratulations. Have a nice day.
Evet arkadaşlar, tamam,
Thank
onu
you.
çıkarttım. Şimdi o zaman Mehmet Bey, sen bir zahmet bunun şeylerine bir yol göster. Bu bence bazı şeyleri kökten yanlış yapıyor. Yani nasıl olmuşsa bu tablo çıkmış, yani şey yok, tutarlılık yok yani sonuçta. Tamam.
Tamam.
Evet, tamam,
Teşekkür ederim, sağ olun.
teşekkür ediyoruz. Biz şimdi raporları doldurmamız lazım ama. Yani şeyler, o raporlar
tamam.
var ya, onlar dolacak, onlar imzalanacak. Evrakları tamamlayacağız. Fakat bu düzeltmeleri getirmedikçe biz o tezin üzerinde, hani en son düzeltme getirip veriliyor ya, biz o kısmı kabul etmeyeceğiz. Yani imzalarımızı o tezin üzerine koymayacağız. Ta ki tablo istediğimiz şekle gelinceye kadar. O son kısımda yazımı düzeltilinceye kadar.
Tamam hocam.
Tamam, oldu.
Evet hocam.
Peki teşekkür ediyorum arkadaşlar. Fatih Hocam, sana da çok teşekkürler. Valla biz Fatih Hoca'yı sürekli bizim bu işlerde değerlendiriyoruz. Sağ olsun, hep koşa koşa geliyor. Ve bir de en önemlisi, yani açık söylemek gerekirse, benim içimde rahat ediyor. Bu tezlerde en azından kabul aşamasında yanlış karar vermemiş oluyoruz. Kendi çalıştığı alanda olunca çok rahat ediyoruz. O bakımdan da özellikle ben Fatih Talu hocamızı sürekli yoruyorum. Artık hakkını helal etsin.
Estağfurullah, helal olsun hocam.
Oldu, sağ ol. Teşekkürler. Hadi hepinize iyi günler. Mehmet, iyi günler.
İyi günler hocam.
Herkese selamlar.
Sağ ol,
Görüşürüz. Sağ ol.
teşekkür ederim.
Teşekkürler.
İyi günler
İyi
Mehmet
günler,
hocam.
sağ olun, sağ
Kolay
ol.
gelsin. Hayırlı
Sağ ol.
günler.